Oh, in Discovery?
Discoverable. Yeah, Discovery. That's what it's called.
Oh,
All right.
are we getting
I'm gonna
people
go
from
ahead.
there?
Yeah.
Oh,
Yeah, you can see how people join on the
Server
Insight.
Insights? Oh, I
Yeah.
didn't think people
Uh,
actually use Discord's Discovery.
I mean, if you go to the Discovery and type hacking or programming, we show up on the list.
Looking, where in the analytics does that show up?
Uh, it's part of. I think it uses our main invite, but that number has just been shooting up a little bit.
All right, well, I'll look into this more later. Sup, you guys. All right, let's talk a little bit about botnets. This is in regards to your guys' assignment. Let me pull that up real quick. There we go. Interns and assignments. All right, sweet. Let me open up the chat here. Awesome. All right, sweet. So, botnets. You guys are tasked with the basic botnet application, and I'm talking super basic. So, typically, the thing is, when you are building a, I'll just keep it more general than that. Botnets can have authentic uses and they can have non-authentic uses. They're kind of just like rootkits in the same sense where they're usually wrapped up with malware in general, but they don't have to be malware. They can have authentic and real uses. It's just about, you know, transparency up front and what you're trying to do with them. Most infamously, you know, botnets in recent years have been for big in the crypto scene in order to, you know, mine for individuals and help increase their wealth. Um, that is a potential legitimate botnet application that you could utilize where maybe people are a part of a mining pool and they willingly log into the mining pool in order to be a part of this network that is cracking stuff. Depending on how you look at it, one is authentic and you are volunteering to do it and be a part of it, and the other one not so much. You're kind of forced upon it. Does that kind of make sense? People wouldn't usually think of something like crypto mining as a botnet, but it is no matter what and how you look at it because you're being distributed work from a central server and then you are working on that item. Um, you know, botnets could have other potential uses like DDoSing is a big one. Spam email campaigns, routing of network traffic through a bot network. So if you're using Tor, you're going to be a part of a botnet because if you're on there, you're usually running also a node on the network, which means people can route their traffic through your computer, which doesn't really look that good if they're looking at child porn because now you got child porn running through your network. Um, so it's all about the gives and takes and what the intent is behind it. Botnets in general are pretty simplistic in their architecture. Usually you have a main server or hub, and then you have listening posts. So depending on your terminology, sometimes this can be called master and slaves. Sometimes this is parents and children. Um, Typically, when I see it, it's usually like the server or God, I'm forgetting the other term. And then these will be like listening posts because they'll sit there and they'll listen and wait for something to do, some type of work. Now, Authentic botnets don't really need to do anything weird in the sense that only they run in like memory only or anything like that. If you're making an authentic botnet, you can have a client that people download and then install on their computers and then run, and then will actively ping out to the server. So typically with botnets, you'll when they get added to the network, if this is a normal commercial network, they'll usually spin up and they'll have a they'll have a repeating ping that happens every X amount of time. That can be 5 seconds, 10 seconds, 10 minutes, 30 minutes, like whatever amount of time you want, you can set that time. And it's on the server then to know, what nodes are currently available for them, and it will have, an internal list of all the currently available nodes. So that way they can distribute work when possible. Now, the issue is that if you're pinging, the ping is your only time in order to send out work. Because typically, if you are running these nodes in an internal network, well, then you're going to have some natting going on, which you guys should all at this time be very familiar with natting, which means these are all running on their own local network, and unless there's port forwarding, which now is a lot more work and it's a lot more noisy if you're doing this for non-legitimate reasons, and if you were doing it for legitimate reasons, a normal user is not going to want to set up port forwarding, which means your only time to send work back to this individual node is going to be when they ping out. And when they ping out, that can be the start of the communication. Usually the pinging out will be TCP requests, because that will initiate a conversation. You cannot just do a UDP request. You'll have to do a full handshake in order to establish that connection. Now, you can mix this with UDP and TCP. So UDP you could send more frequently, just as, hey, I'm alive. I'm still alive. Every couple of seconds you can just keep saying, hey, I'm alive, I'm alive, I'm alive. And then you can have a TCP request that gets sent every X amount of seconds back to the server. Now, once something gets established, then you are able to send work back to the client. This also starts the potential issues, because what if your client is outdated or only supports X amount of features? So let's say you have a botnet that's for cracking passwords, let's say. So potential malicious reason. But you made these clients so they only support and are able to crack MD5 hashes. Well, now you want to start cracking, SHA, whatever SHA version it may be. You're trying to crack SHA versions. Well, what do? Do you have all these clients update and send them an update? Or do you, over the network, send them, if it's written in C, like a DLL or something, where they can then put on disk and then just start referring to, or something they can load up in memory to now adapt their application in order to support these new items? It is totally up to you. The thing is, if it's going to be in memory, it's not something that they'll be able to, it won't persist after relaunch. But that's something also you need to be aware of, because anytime you want to add new functionality, you're going to need to update these clients in some type of way. If you are being malicious, you're going to want it to all be in memory, and keep your footprint as small as possible. If it's not malicious, you could probably force updates. But then comes tasking. So being able to break up your items correctly in order to work across the multiple nodes. Now, this is a kind of difficult task for most beginner devs because typically we all think in CPU, which is very linear in its execution. You go task 1, task 2, task 3, task 10,000. You go purely down a single stack. In regards to botnets, though, you need to think more like a GPU, where tasks are usually can be done in the thousands at the exact same time. And you can go down these stacks at the exact same time in the thousands. And it's just a huge performance boost. But you can't compute things in parallel if they depend on each other. So if this data right here depends on the result of this data right here, well, now you need to wait. You can't compute these in parallel. You have to first wait for this data to be computed on in order to then compute on this guy here, which means this guy would have to be moved down here on the second row. This is a typical issue that individuals will run into because it's just kind of a mindset thing. It's hard for individuals to conceptualize running parallel processing. So not all data that you're trying to execute on is suitable also for parallel execution. You can sure hack it, like I said, and have it so it in this parallel execution format, you are being more linear, like in a CPU format. That's totally doable, but you won't be getting the same performance benefits. You'll be getting slower performance benefits. So, going back to the botnet, something typically you always want to relay back is maybe some crucial information, what the OS is, what current software they have on their machine. If you're using something like Python here at the edge, maybe the Python version, what current pip modules are installed, because if you're doing, let's say, a machine learning application across a botnet, you need to make sure that they all have the exact same modules that are running and their same version number and the same, compatibility. Because if they are different, you could get different results, which would mess everything up. So it's important to make sure everything is compatible. Additionally, you might want to be sending back information like, do they have a CPU? How many cores do they have? How much RAM do they have? How much GPU resources do they have? Do they even have GPU resources to begin with? And logging all that information here at the server. So that way, if a task is given to them which only works on CPU, it will go to all the devices that are allowing for CPU compute. And if there's a task that requires GPU compute, you're not sending tasks to these individuals if they don't have GPU compute, because now you're going to mess a lot of this up. Does that make sense so far? Do you guys have any questions? So you guys are typing, so we're just waiting right now. All these botnet executables, libraries, etc., are just chilling on the file system among other files. Potentially, yes. If it's a legitimate application, then yes. You will want to put everything in the file system. It's just like any other application you would install on your computer, whether that's Discord, Spotify, etc. You can even give the user a graphical interface where they can have a button that says, be a part of the botnet or not. For example, the last one that I made has a little graphical interface which allows individuals to allocate CPU resources, RAM resources, and GPU resources I don't think I had hard disk resources, but that's something you would also want to um, add, is because if you're computing a lot of stuff, let's say each individual is getting like a gigabyte of data to compute on, you want to make sure you're cleaning up after yourself, but make sure also that the end user has enough allocated hard disk space to intercept that data and then run on. And then this would dictate how many of their resources I would be utilizing. This is more of a legitimate thing. But if it is a non-legitimate botnet, then you definitely want something that is headless and has a very, very small footprint. And essentially on startup of the botnet, it will reach out to the server and be like, hey, this is my startup sequence. Send me back everything I need to do further computation. And usually all the data that's sent back will be loaded up in memory and only be in memory and never touch disk. And it will include all of the code that's required in order to execute on whatever data the server may send back to the listening post. Does that make sense? Is UDP viable for a botnet? Yes, UDP is viable for the botnet in regards to like I don't know if calling the packets heartbeat packets would be completely correct, but essentially just sending it out to the server that, hey, I'm here, I exist, I'm alive, because it's very small. It's just one single packet that goes across the network, and you're sending this semi-frequently. So if a packet or two don't make it across the network, you'll eventually get one across the network that finally connects to the server. Now, there are arguments to be made that usually you got to think about covering your tracks, because if you're on a network and you are sending traffic across the wire that's going to some weird port that doesn't have a known associated service, you're going to be an outlier, and people are going to notice that if this is for more like malicious reasons. It's going to be very obvious. So typically what you want to do is utilize ports that are for well-known services and form your packets to look like well-formed services. So for example, maybe you don't use UDP at all and you use purely TCP, and you have your server that's running on port 80, so it looks like it's a actual web service, and when you connect out to it and ping that and you say I'm alive, you're actually sending an HTML looking like header response, and it just kind of looks like web traffic. That would be a way to kind of hide what you're doing on the network. Now, this is just a single way to do it. I wouldn't really recommend 80 because that's going to be plain text. So if someone was looking at the packets, they could see the data is kind of weird. So potentially doing it over 443, so that's going to be HTTPS. At least it will be encrypted, but more realistically, you're going to want to use a port that usually sends binary data across and hide it in the binary data. So for example, maybe you're going to be using it on, God, what's the port for SMB? What's the port for SMB? Come on, someone. FTP is weird. Most people won't be doing FTP traffic normally. SMB. SMB port, let's see here. 445. So 445. So you might want to send data over 445, and that way it's more binary based data. And you want it to look super legit, so what you would do is kind of like what they'll do in steganography. You'll use the lowest I'm blanking on all these terms right now. You'll use the lowest influential bit. That's not the proper term. I'm blanking on it right now. but you'll use that in order to indicate various different statuses, or maybe you'll hide in your TCP checksum, some information in regards to your botnet. Basically, you want to hide in plain sight as much as possible when it comes to using it for potentially malicious reasons. You don't want to make it obvious. If you make it obvious, people are going to find you, and it's going to be taken down. And then when the forensic team comes around, if you're being obvious about that, you're probably being obvious about other stuff, so they can probably track you down. So that's the thing, is tradecraft. That's what all governments around the world are spending big money on researching and fine-tuning, is tradecraft and how to be as silent and inconspicuous as possible. That's what all the most highest rated secrets are for the government, is going to be in regards to tradecraft. So this architecture and what I'm telling you is all very much known. Like, this is pretty much, if you want to research and make a botnet, this is it. But how you execute and hide that your item is an actual botnet in a malicious for malicious reasons, that's going to be underneath your tradecraft, and you need to balance that for what you're doing. Because if you're going after normal users like yourself on a normal network, and I put a botnet on your machine, you're probably not looking at your network, and you'll never know that it was on there. So I could be maybe a little more loud and maybe connect to port 80, or not even connect to port 80 at all, and just use my own custom port on, I don't know, 31 to, let's say 3012. Maybe I'm just using that, because you won't really notice unless you see a lot of your resources, like your CPU, RAM, and so forth, just skyrocket. And you'll wonder why your computer's being slow. So that's another thing, is if you are on someone's computer, do you want to just run it right into the ground real quick and just go ham, or do you want to just be very silent and using a little bit of resources, or do you want to analyze what their typical usage is and say, oh, they're usually awake between this hour and this hour. So during outside of these hours, I'm going to sit silent, do absolutely nothing, and then outside those hours, that's when I'm going to crank everything up to 100% and start going ham and utilizing every resource possible on this machine. It's totally up to you. Now, depending on the antivirus you have, so for example, if you have Norton comes with a botnet essentially in their application. It's not showing up right now. I think it's this. So basically it's this. You can make it so Norton will analyze when you use your computer and when you're not. And when you're not using your computer, they will start a Ethereum miner on your computer. And when you get back on your computer, they'll turn off the Ethereum miner. And they take a percentage of what you mine from this miner. So this is essentially a botnet. This is you connecting to a network of other devices to do crypto mining, and it is utilizing, like I said, X time to X time. It will analyze and figure out what time you are using your computer and what time you're not. And when you're not, it will literally crank your resources up to 100% and dedicate them all to this process. And it is super, super intense. That makes sense? Any questions on that? So, in regards to your guys' project, you're going to be making a dispatcher. There we go. A dispatcher and a listening post. So this will be your dispatcher, which will dispatch tasks, and then these guys will be your listening posts. Now, there will be one dispatcher to connect all these listening posts. That's typically how it is there's usually one master service, but if you're really good at load balancing and your network is really, really big, you could have multiple dispatchers that you're going to have to make this into 3 layers now, where you have a master service that controls the dispatchers, and then the dispatchers will control all of the listening posts. So in order to keep it simple, just one single dispatcher to handle all of your listening posts. So according to your application, you need to have a dispatcher that will then be able to send commands to the listening posts to then execute on some type of data. What type of data? Well, right now we're doing Fibonacci sequences, and you're going to have to compute those on your listener posts. So essentially, what your network should be doing, let's go ahead and make a new one, is your dispatcher will sit here and will be listening for new nodes to join the network. Once you have a listening node spun up, your listening node should start pinging out. How you want to do your pinging out, I don't really care. Just set it out so it pings out and the dispatcher knows that this is a thing that's alive. And when you should be able to then, let me make a couple more listening posts here. You should then be able to execute some type of command on the dispatcher in order to execute some type of command on the listening posts in order for them to start computing stuff. So for example, in our application that you guys need to develop here, you need to be computing Fibonacci sequences. So essentially the dispatcher will get a bunch of numbers, let's say 88, let's say 1, let's say 10,001, and 2, 8, 5, 6, 7, 1. All four of these numbers will be submitted at once to the dispatcher, and now the dispatcher needs to send these listening posts work. So 3 of these should immediately be sent off, and 1 should remain in the queue. These 3 should be sent off to each listener post, and each listener post needs to validate whether those numbers are part of the Fibonacci sequence or not. So is 88 a part of it? Is 1 a part of it? Or is what is this? 100,001. Is that a part of the Fibonacci sequence? After it's done computing and validating, it should then send a response back to the dispatcher saying yay or nay, and you should be logging all the results in your dispatcher. Does that make sense? So additional things that you guys are going to want to be sending is IP address, MAC address, privilege levels, just various different information so you know what is capable on your listening posts and what's not. Additionally, the MAC and IP addresses will be for you, that's just required because you need to know where you're sending your individual items and who is in charge of those individual items, and you can also then generate based off of those 2 items, the IP and the MAC, a unique identifier code for that single connection. So let's see here. This will basically tell you number pass. Yes, make sure that you are handling all errors and invalid input, because if I am if you have this botnet and it is for malicious needs and you have it on my computer and I see it, maybe I want to fuck with you. Maybe I don't want to just remove it right away. I want to analyze what type of data you're sending around the network and be like, okay, it's usually structured and formatted in this way. So instead of sending the data structured in the exact way it needs to be sent, maybe I'm going to send you a malformed packet. And you being, let's say in this situation, a not so good dev, haven't taken the time to validate your packets and make sure they are in the exact format you require. So once you get it, your program blows the fuck up, your dispatcher goes down, and your network basically dies. And then I install your listening post, or maybe I keep it on, or maybe I move it to a laptop that I have, and every time I notice the dispatcher comes back online, I immediately send the malformed packet back to you and take down your dispatcher. you will get mad real quick and you may be very confused and not understand what the hell is going on, because every time you start up your application, it will be running for 10 seconds to maybe a minute before it gets automatically shut down, and you're getting these segfault errors, but you don't know why, and basically you can DOS the individual who's running the network. So let's say, give me like 2 seconds. I need to use the restroom, but while I'm there, think of some questions, add it to the chat, and I'll answer them when I come back right back. Alright, I'm back. Let's look through these questions. So say the node boots up. Node that initiates. Yes, the node will initiate contact with the dispatcher every single time, because if not, that means the dispatcher has to send traffic across all possible IPs, and you'll run into the issue of natting again, where any traffic that you send will be immediately blocked unless there's already established connection. So if there's not an established connection, most of your traffic is just going to be blocked unless there's already port forwarding set up. You mentioned needing a MAC address. Is this for logging? Which node does what? It's just for identification. So let's say you have like 5 different nodes that are on the same IP address. So you want to make sure that, all the connections that you make will happen automatically, because those will be unique connection IDs. But you might want to double check that you're not on the same device. So checking the MAC addresses will make sure that you're not running 5 listening posts on the exact same device, which may eat up a lot more resources than you want. Or I don't know, it's just always good to have the MAC address, because it shows that you are on a different potential device, because when you are sending traffic out, all you're going to see is the external IP, unless you're gathering also the internal IP address through your application. When you're sending communications across, all the dispatcher will see when you're sending communications across normally is going to be the external IP. I'm going to do external. So you can send also the internal ID from within your application, pack it into your packet, and send it across. This would be useful for various different reasons. One would also be making sure you're not running the same application on the same computer, but also maybe you want to discover how an internal network's layout is, or do various other non-nice things. You would want that information. All right, let's see here. Finally, if I send data when the dispatcher receives a ping, how do I do this? Pings make sense to be ICMP or UDP? Up to you. Hold on. You're going to want it typically just to be UDP traffic. You could hide it in other traffic like ICMP, but now the challenge is, if you are using that, how are you going to disguise the data that you want to send across inside of that packet? So something we have not hit on, which is what you guys should start looking into next. Is let's go here, ICMP. Is you guys should start looking into and researching the individual packets and what makes up those packets. So if we look at ICMP, for example, you might think you can just shove some data in the ICMP packet. Well, you need to figure out what the layout of the ICMP packet is. So this looks like a normal TCP header. Let's see, ICMP layout. There we go. So your ICMP packet is going to have at least 8 bytes in size, which is going to be ICMP header, and then you're going to have some ICMP data. What that data is, you'll have to look into the layout of that data. Maybe this is somewhere where you can load information. But at the very beginning of your ICMP packet, in order to make one, you're going to 1 byte of that data is going to need to be the type of ICMP packet you're sending. So this will be, whether it's a ping or those various other items you can do. Second is code. I don't remember what the code is used for. Next is the checksum, so that's the integrity of the packet. Third is going to be your ID, and the next will be the sequence number. And you'll see each one of these are going to have individual allocated byte sizes to them, so you're going to need to be filling out this accordingly, and you're going to need to research how the packet is appropriately sent, because like I said, if you're trying to be super sneaky, you should make sure this looks very legit. You don't want to have it look like it's an outlier item. If I repeatedly ping in TCP, it just builds up a huge queue of incoming connections at the dispatcher, which no. It will not do that. You should be making your dispatcher spin off threads to handle every single new communication. You should not, this is not going to be a single threaded application. This should be a multi-threaded application. So if you're not used to using threading in C, C++, or C#, you're going to need to learn it, because you need to make this a multi-threaded application, and these should also be ideally multi-threaded applications. The listening posts you might be able to get away with, but the dispatcher 100% needs to be multi-threaded application, so that way each thread is handling the current listening post that it's in charge of, and it's constantly listening from data from that listening post. And maybe it keeps this is more so important for when you actually establish some type of workload. Maybe you want to keep that connection alive the entire time. But regardless, if 10 of these items or listening posts try to connect at the exact same time, you don't want to put them in a queue, because it's going to be a lot of traffic and a lot of waiting, and who knows, maybe each connection for some reason takes a minute to process. So you need to make it look authentic, but also to give the user, if this is a legit application, a good experience. You need to have it as a multi-thread application where every thread will handle a new incoming session. So in essence, don't use proper protocols. So you're saying ping ICMP responds with ICMP2. Yes. ICMP packets respond with ICMP packets. So both packets on both sides would need to be ICMP. You can use proper protocols. That is 100% fine. You just need to research the packet layout and make sure that you are following the proper packet layout size or in integrity. So for example, if you wanted to hide stuff in the TCP header, so this is for IVP4, so this would be the IP header, my bad. I don't know why it's labeled ICMP, but essentially here in your version number and flags and fragment offset and checksum, particularly the flags, fragment offset, and checksum, well, I guess not too much in flags, but these are areas where you could potentially hide data that you want to send across the network, and you can have everything else in the payload look like normal network traffic. So let me just go to IPv4, not 5. There we go. So like I said, this is the top header part is going to be 20 bytes, and then there's 20 more bytes for the options, and then each packet can have up to 65,000 of bytes of data in its data packet. So you could stuff information in the header, you could stuff information in the options or in the data. Totally up to you on how you want to do it and how obscure you want to make it. Any questions on that? And this goes for anything. So if you want to do SMB, you can check out the SMB packet layouts, which should be in here somewhere. So you'll need to, these are not very informative, but this is something where you're going to need to look at probably at the code base because there might not be nice images. Using Wireshark is nice because sometimes Wireshark will have the breakout of this information for you. So they'll tell you, oh, when you highlight over certain things, let's go ahead and load up Wireshark so I can show you guys. Gosh darn, it's going to do this like 5 times. Gosh darn it, just load it. Okay, here we go. No! Okay, so we'll go ahead and stop this, and you'll see that when you look in your packet here, so here's the raw data packet, and you can highlight over, it will auto highlight over the individual items in your packet. And if you click on it, it will tell you what that correlates to. So this correlates to the fragment offset in my IPv4 header, which you can see this is the IPv4 header. If we look here, this will be your MAC addresses, so your source and destination address. So you can see, you know, every packet always has, it's wrapped around your Ethernet header, which is going to highlight the MAC addresses that it came from and it should be going to. You'll also see that it will have the next, God, I'm forgetting on the packet, but it should have, looks like there's another source in, there we go. I'm forgetting what these items are particularly. You can look them up more in depth, but this will dictate what type of wrappers in the next. So 0800 is the indicator for IVP4. So that means the next item in this packet is going to be your IVP4 header. And so this is your header length, which is 20 bytes. Usually headers are going to be 20 bytes. You won't have the options on there. So after that, you can see that this usually is 00. I can't remember what exactly it's for, but after that, I believe it's this item. Here we go. Towards the end of it, end of the packet is where you're going to have your source and destination address. And before that will be, you know, your time to live, your checksum, and everything in regards to that. And this is the, and then after that, in your IVP4 packet, it will tell you what's up next. So 11 is the indicator for UDP. So that means the next packet after your IVP4 packet is going to be your UDP packet, which here it is right here. And if this was a well-known service, which this isn't, it will break down what exactly the structure of this UDP packet is. But as you can see, it's not really broken down. If we look through here, maybe we can find something else besides, here we go. So here we have UDP traffic, and in UDP traffic we have RTCP traffic. And inside here you can see that it supports the breakdown of your RTCP packet. So it will tell you what all the individual items in that packet mean and what they are for. And so you can, you know, potentially use this to hide information. But if you want to be super sneaky, you're going to need to research and take time looking into these packets and figuring out like how you want to hide your data. That makes sense? All right, what other questions do you guys have right now? As just a general overview, you must have a dispatcher and a listening post, and you should be able to spawn multiple listening posts. The dispatcher should be able to handle all of them. If you're going to write this in C, or honestly any application that you write this in, shove it in a Docker container, so I don't have to worry about compatibility issues and it not running on a machine. So all of this should run in a Docker container. Give it and turn it in a Docker container packed away. So one container should be the dispatcher and the other container should be the listening post. And I should be able to just load up the dispatcher and 1,000 listening posts, and all those listening posts should be able to connect. And if I give the dispatcher data, this data I would recommend using the REST API endpoint. So make a REST API endpoint on your dispatcher that will then take data, and then that data will be distributing to your listening posts. Do not give me a static text file or something like that where it's only a one-time run, or I need to log in the machine and like dump text. No, I want to use a REST endpoint to send data to the dispatcher for it to then send data to listening posts, which means you're going to also need to make a way to separate listening posts to someone that's sending like a master data, like a master controller or something that will send data to your dispatcher. Like I said before, IP, MAC, and privilege levels you should be logging in your application. Your application on the listening post side should be validating whether a number is a part of the Fibonacci sequence or not, which means you need to develop an algorithm to compute Fibonacci sequences, and you're going to need to write this in C, C++, or C Sharp. I highly recommend doing it in C or C++ because it's more authentic. And make sure you are handling errors, whether that's a bad request from the master controller and I give you bad REST point data, or it's bad numbers. Maybe I gave you a floating point value. That's bad. Maybe it's a string instead. That's bad data. It should handle it. Listening posts, if they're sending bad packets back, it should handle it. You should be handling improper data. Because we need to use REST API, is using JSON libraries allowed? Sure, I will allow it, so it's not super annoying. No, there are Windows container images, but don't use them. Just use a Linux container. Your application will run just fine in a Linux container. Maybe get REST API to run in Python. You can do whatever you want. If you want to run the REST API in Python, that's just fine. The dispatcher can be more sloppy is not the right word, but it could be more crazy in its writing. Like you could have Python, it could be all Python, or it could be all C, or it could be a mix of both. It's totally up to you, but if you need to figure out a good way to send data then from your Python application to your dispatcher, which is written in C, if you do that, which at that point you might as well just write it in C. You do not need to use WinAPI. All the normal C commands will work on Linux and Windows. Do not use kernel commands for your application. Guarantee you most of the things you do are not WinAPI specific. Malloc is not WinAPI specific. The networking library isn't OS specific. None of those are going to be OS specific. So you can write it in Windows and then compile it on Linux without issue. I'm telling you right now, the networking library in C is not OS specific. I've written many applications in Linux, compiled them on there, compiled them on Mac, and compiled them on my Windows, and got working copies from the same build. The only issue I will have is on my compiler, I may need additional flags. So, for example, on Mac OS, you'll need additional flags, but the C library is the same on every single OS. They are not OS specific. Let's go here and check out some repos. This is the Python one. So your listener will be utilizing socket, which is OS agnostic. All of these commands for bind, HT on L, or however these are pronounced, these commands are OS agnostic. So if these are what you usually use, these should be what you're usually using. It will work just fine on any OS, because C does not. That was the whole point of C. C was not an OS specific language. It was the first one, because assembly underneath it is OS specific, and it's not just OS specific, but CPU specific. C was made and invented and used because it was an abstraction layer where you could write once and then have it work on multiple different boxes. Of course, you would need a new compiler, but that would be the only thing you would swap out, is the compiler. You should be using the default C libraries when you are making these applications. So WS2 TCP IP is not what you're going to want to be utilizing, unless I'm not sure if that's a C or C++ thing, or if I don't think that's a C sharp. I don't think C sharp uses header files, but you're going to want to be using the base C libraries. Any questions on that? Raw sockets are not OS. Raw sockets are OS agnostic. Also, you can make raw sockets and send straight up struct data across them if that's what you want to do. Also, but I would recommend just use REST API, because that is more practical and what people will be using. Because it, like I said, on the dispatcher level, it doesn't matter. If you want to use raw sockets from the listener to the dispatcher, you can totally do that. I've listed ways for you to hide your data, but you don't have to hide your data in this application. You can do a raw TCP socket with your own type of packet information that you send across to your listening posts. That is completely fine. But on the dispatcher end, you don't need to be so secretive in that sense. You can just use a REST API endpoint, so that way you can pass that off to some type of UI designer that you have, which then can make a nice pretty graphical interface, or can make a website to get paired with your dispatcher. So then you can utilize your dispatcher to have a nice interface where your team can then use your dispatcher to be sent to send data across to the listening post. Any questions on that? I don't have any right now. Sure, we'll have a lot during the coding process. This is something new for me, but it looks exciting. Yes, this is going to be new. It's going to be exciting. It should not be too complex. The most complex thing is you developing your listening connection and then utilizing your threading. I don't even know where my threading is. Here we go. And then utilizing threading in order to handle your incoming applications. So this one was sending libraries and uploading them strictly in memory. So you won't be doing stuff like that, and that would be more specific to the OS that you're launching on. So this one was for Ubuntu. So the SO files were all for like Ubuntu and compiled for Ubuntu machines. So totally up to you on how you want to do it, but threads and listening is going to be the most important thing. For your Fibonacci sequence, you can just Google Fibonacci sequence algorithm. Let's click on this, and you should get a Fibonacci algorithm to you right here real quick. So here you go. Here's a Fibonacci algorithm that you can use. And conveniently, it's written in C++. Here's one for C. So you can just use this. Any other questions? All right. If there are no other questions, then that concludes today's sessions. I'll hang around for a second if anyone else has any remaining